Professor and I'm the Zennstrom Chair for Climate Change Leadership at the University of Uppsala. I'm absolutely delighted to be able to welcome Dr. Claire Craig here today. Claire is somebody I've known for a few years and who I hugely respect. She's one of the people who has managed to cross so many different boundaries, from industry to policy to the academy. I'm hugely delighted that you're going to be taking up the new role as Provost of Queen's College, Oxford, the first woman to do so. So a huge leap forward, I think, for Oxford colleges, and I'm very lucky to have you. But Claire and I have been having some really interesting conversations about the relationship between science and futures and government and decision making for a few years now. So I was delighted that you were going to be in Sweden anyway, and I could persuade you to come here. So we're really pleased that you're here. Claire will talk probably for about 40 odd minutes, and then we'll have time for a conversation. So
thank you.
Okay, thank you.
Well, thank you so much, Kerry, and I'm really glad to have the opportunity to talk about my two favourite subjects. So I managed to get them both in the title, which is science in government and futures in government. And what I'm going to talk about is based, and I think the first thing I should say is I'm what you might call a reflective practitioner. So I'm not an academic, although I've worked with scientists most of my life. The majority of the experience that I'm talking about here is from inside of government, and in particular, it's inside of the national government in the UK. Right? And it's about providing scientific advice to ministers under a range of different circumstances. But what I hope and believe is that the moments of decision making where different forms of knowledge come together for ministers in government is almost like a kind of microcosm of a whole lot of bigger issues about how knowledge is created and how decisions get made, both privately, personally and collectively. So it's kind of an easy form to study of the way that science gets into government. So you can pull more general lessons out beyond the UK or beyond government specifically. So anyway. And then the futures part, again, futures is a really broad term, but the core of what I'm going to talk about is futures from the experience in a government programme in the UK called Foresight, which is quite a common name, but unusually the UK for 20 years has run in its science kind of heading a programme of science-based futures to inform public decisions. So that I think will form the basis of what I'm going to talk about. Now, I'm quite used to talking, because I'm now at the Royal Society, which is the British National Academy for Physical and Natural Scientists, and so I'm used to talking to physical scientists. They find this really shocking, okay? And they find it really shocking because really what this is saying is, if you are trying to speak truth in the context of making decisions or having debates, perfectly true statements are so bounded, so qualified, so expressed in the terminology of the discipline or the sector or the group, that they really aren't useful for any kind of more general debate with people across boundaries or in a broader situation. So a true statement may not be useful, and indeed, and this is what scientists find really hard, anything that they say that can be useful is ultimately not really true in that sort of way. Now that statement is probably not true. So, now I'm going to start with a kind of moment that I think is a real microcosm of all sorts of issues about how you get scientific knowledge into decisions. So this is an example of what Roger Pielke, who's one of the scholars of science in government, science in policy based in the States, what he describes as tornado and abortion politics. Because again, in the kind of environment, kind of political environment in many democracies within the West, there's a conversation, the discussion of evidence-based decision-making, evidence-based policy. And one of the first things you learn when you're actually working with ministers, with decision-makers, is it's really not at all like that, not ever like that. And Pielke sort of sets a spectrum. His terms are American, but essentially in US politics, there is no science that will make a difference to the political outcomes on abortion. And on the whole, when you have a tornado coming, nobody stops to say, you know, what's a tornado's politics or values. So abortion debates are those where values are primarily at stake, and tornado issues, policy or political decisions, are ones where values on the whole don't matter too much. It's really people are willing to listen to the evidence. And an example of tornado politics from the UK context is Fukushima. So this is a UK perspective, but bear with me. So Fukushima, for those who can remember it, emergency during the massive and tragic Japanese earthquake and tsunami. Massive uncertainty about what was happening in this nuclear plant over a period of 2 or 3 days. Interestingly, in the media at the time, there was some evidence that the 15,000 plus people who died in the tsunami, some of those deaths were being attributed to nuclear fallout even at this time. In other words, the confusion in the kind of disaster reporting, political, public discussion. Anyhow, in the UK, the question, as for many other non-Japanese nations, was should citizens be advised to stay in Tokyo? Because it wasn't clear if this thing went really nasty, whether staying in Tokyo was safer than getting into an aircraft and flying supersonically away, which itself has extra radiation. If you fly high, you get more radiation. So there's a radiation risk from going, a radiation risk from staying. In the UK, there's an established mechanism that the government chief scientific advisor, which is a post which has been around since the Second World War, calls together a group. That group looks at the evidence available, the meteorology, the epidemic, the health science, what nuclear engineers were saying about what might be happening in Fukushima, many different forms of evidence, psychologists in terms of what would happen if you make an announcement that people should be evacuated, that sort of thing. Anyhow, got them together over the course of a few hours, so remember this is happening in real time. This is a political decision, should the Prime Minister say to people they should stay in Tokyo or they should go. Political decisions clear, evidence has to come in very rapidly, gets combined in the head of the government chief scientific advisor, who says something to the Prime Minister, who has to say something to the public, and in particular to the embassy. And in fact, in this example, what happened was the British scientific advisor said that the risks of going were greater than the risks of staying. So in the worst case scenario, plausible worst case scenario, if you stay in Tokyo, whatever happens in Fukushima, it's very unlikely that the conditions of weather, etc., would mean you get more radiation if you stay than if you went. So the advice was to stay on the basis of the risk. And the government chief scientific advisor talks about speaking to the Prime Minister, in the heat of all that was going on. And basically, Prime Minister, here's some risks, here's the problem. And the Prime Minister says that. So to the Prime Minister, to the scientist, he said, are you sure? Yeah? Are you sure that the risk of staying is less than the risk of going? And the government saying, well, can't say really, well, it depends what you mean by sure. Yeah? Kind of, sort of, off the record says, well, yes, pretty sure. And then the Prime Minister says, well, are you sure you're sure? Because in the end, the Prime Minister's taking a decision on which lives depend. And that's also interesting from the point of view of those who give, technocratic, detailed, highly evidenced advice in political context. There are moments when it's really just about a trust-based relationship and about the language of expressing uncertainty. So what Fukushima, the British advice was stay, the British stayed. Some other nation states advised their citizens to go. I don't know what the Swedes did. The French left, and the Americans stayed, and I don't know beyond that. So on the same scientific evidence, different nation states took different views. Interestingly, although the decision was tornado politics, essentially it was about the risks at the moment, the consequences of that decision were quite long term. So it is almost certainly the case that Japanese government willingness to continue investing in energy, nuclear energy in this instance, in the UK, was heightened because of goodwill around what the British did during that particular emergency. In fact, they stayed and they also gave support to the Japanese government. However, points more generally. One, communicating uncertainty. Two, the fact that it was multiple disciplines. And this is another thing for scientists, and I'm sorry, I talk about scientists, but I hope most of what I say is generalisable to research more generally, to scholarship and science, is that no big policy question can be solved by one discipline. And therein lies much of the fascination, the challenge, the difficulty and the pleasure of doing the kind of boundary work that people like those I've worked with, and some of what I've done, and much of what Kerry and I talk about, is about. It's bringing different forms of knowledge together to provide advice to the questions which they are what they are. They cannot be fitted into disciplinary boundaries. And then the last is that the science doesn't inform the outcome. Right, combining evidence. I just wanted to flag combining evidence. So one of the questions about how you get science into decision making is kind of the tensions around the fact that on the whole, researchers are creating new knowledge, and for rapidly changing policy, what matters is bringing together existing knowledge rapidly, and that's not often well regarded. So you don't get professorships or tenure track by synthesising existing knowledge by and large. You don't get funded for it in advance. And you can't always publish it in high quality journals and so on. But what there are, these are primarily British but not all, there are mechanisms for, in areas where it's clear that evidence needs to be brought together consistently, there are mechanisms for doing that. We did some work at the Royal Society with other national academies about the conditions for good synthesis, good bringing together of different disciplines. But you've got everything here from the, somewhere it should be the IPCC. So the kind of gold standard in some sense is the IPCC, at least in terms of the physical and natural sciences and what it brings together, a mechanism for collecting and co-producing and synthesizing knowledge through to more specific forms. The other point that I want to bring out, and then I'm going to move on to futures, from that Fukushima example, was this business of the evidence as defined by, as currently understood by most researchers. The evidence does not determine the policy outcome and should not determine the policy outcome. And these two examples are from British politics. So on the left, for those of you who don't recognise it, is ecstasy. And on the right, which is less recognised, is the drug cat, which is a mildly hallucinogenic chewable thing, substance. And in the UK there's a formal advisory committee that gives guidance on the harms and benefits from drugs to the Home Secretary who legislates on drugs, and in particular which drugs should be regulated and made criminal to possess or whatever it might be. On ecstasy, about 10 years ago, there was a moment when